Welcome to video 8.5a, the Side-Splitter Theorem. Here's the theorem. If a line is parallel to one side of a triangle and it intersects to their two sides, then it divides those sides proportionally. So here's an example. I've got a triangle. This line is parallel. It divides these sides proportionally. I can write all these proportions. AB is to BC, so left top is to left bottom, is equal to AE over ED, right top over right bottom. Or I could have written AB over AC, top to whole, over top to whole. Or I could have gone AC is to BC, whole to bottom, whole to bottom. The key is just be consistent. Okay? So here's an example, example 1. BE is parallel to CD. That's how the side-splitter theorem works. We're given these dimensions. AB is 4, BC is 2, AE is 7, BE is 6, and we're asked to find ED, and we're asked to find CD. I'll just call this one X, and I'll call this one Y to make the calculations easier. All right, I've already stated here, we're going to use a side splitter for this and similar triangles for this. I just want to emphasize, the side splitter is used to find sides. ED is one of those sides. We cannot use the side splitter to find bottoms. Okay? So to find CD, I'm going to be using similar triangles. So you got to keep in mind those two different methods. Okay, so let's use the side-splitter theorem to find X, which is ED. All right, you can set up however you want. You could say X is to 7. X is to 7. Now we're going to be consistent. That would be 2 is to 4. So I went bottom to top, bottom to top. And then I cross multiply. And I got 4x equals 14, x equals 14 over 4, x equals 7 halves, and that's the same as ED. So ED equals 7 halves. Okay, now I'm going to find CD, and again I can't find that by the side-splitter theorem. I'm going to use similar triangles. How do I know I've got similar triangles? Well, this triangle and this triangle are certainly similar. They have that angle the same measure and corresponding angles over here and over there as well. Okay, so I know I've got similar triangles. Let's set up a proportion with the similar triangles. So I want to find what, so I could just say this. I could just say small things are to big things. So I could say this small x is to this big y. Then I've got to keep the proportion, something I know, this small 4, and this is where students make a mistake, to this big 6. Okay, so again, setting up proportion. Then I can just cross multiply. So we get 4y equals 36, divide by 4, divide by 4, y equals 9, so CD equals 9. So there you have it, the side-splitter theorem in an example using that, along with similar triangles.